This is geotrig lesson 7, guys. We are going to talk about reasoning today, inductive, deductive reasoning, and then we're going to go into a little bit of logic puzzles, just to define if something's logical or illogical, so valid or invalid arguments. So before we get there, we're going to have to talk about different things here, and we're going to talk about inductive reasoning. Inductive reasoning, guys, is the process when you try to find a rule. Okay? You try to find a rule. That's inductive. Or induce is to formulate, okay, in math. Now, deductive reasoning is the process of using the rule once it's established. So, deductive is saying that when you sampled a group of things and you came up with a rule that it looks like there's 50% girls and 50% boys in the classroom, then we can deduce that the rest of the classrooms in this building are that way, or the rest of the school is that way. Inductive reasoning is that process of finding the rule. Of, hey, I am going to formulate a rule of how many boys and how many girls are in the school, and you gather up the process to create that. Now, big thing here is the fact that of this line right here. If a rule is false, but it's used properly, the conclusion reached can be false. Interesting. So, we're going to use that to our advantage sometimes. I've got some examples coming up on that. And then the study of logical reasoning is a study of the proper use of rules, and the truth or falsity of the rule is not a consideration. So in these problems, just because pigs can't fly in the real world doesn't necessarily mean that in this world that we are going to construct a little bit later on here, doesn't mean that it can't happen there. Okay? So we can construct anything we want to say, and if it follows the right process, it can be logical, or it can be valid, you should say. It can be invalid or valid. A syllogism, something along those lines, I can't say that properly right now, is a formal reasoning process in which a conclusion is reached by using two statements called premises. We have a universal affirmative, guys. The universal affirmative affirms that all members of a group possess it. It's called a major premise. And then you got a minor premise, identifies someone as part of that group. And then the conclusion would only follow that the person that you identified as a member of the group possesses the quality of that group. Hence, the example with the pig. All pigs fly. Harry is a pig. So Harry flies. That is a logical, valid argument. Because the reason why this is in this math book, and it's here, is because, hey guys, I can jump over a car. Most likely, most of you guys would be like saying, hey, prove it.
You probably could.
So, here we go. I can jump over a car.
Oh my.
I just did it. So, everybody wants to be proved that you can do something or you can't do something. How do we do that is by a logical process. And when you do your math problems, that is a logical process, step by step. And eventually we will be doing something called proofs. You can't just jump to the conclusion and say, because. It's not good enough. And so what we need to do is you need to go step by step on everything and back it up with the reason why. A valid argument, guys, is if the conclusion of a logical consequence of a member being part of the group that has the common property, then it's called valid. It's invalid, guys, if a member is not part of the group, but you say he contains the quality of the group or not. So, all pigs fly. Henry's a chicken, therefore he flies. That's an invalid argument. Because the only thing we know in this world is that pigs can fly. I could care less. I don't know what chickens do. It's not logical. In real life, yeah, chickens fly. Sure, great. But not in this argument. Okay, any questions? Can I move on? Again, you can print this stuff out. There's nothing really to fill in here. But now, this is what the big stuff is. This is where we're going to go back and say, is it valid or is it invalid? They all will follow this pattern, guys, right here. We have a major premise, you have a minor premise, and then you have a conclusion. The major premise, again, states a group of people have a property or characteristic. The minor premise should put somebody in that group. And then the conclusion is that the person you put into the group has the quality of the group. So, number 1, valid or invalid?
Invalid.
All men are mortal. Mr. Konchak is a man. Therefore, Mr. Konchak is mortal. Valid or invalid? Valid. The sum of the exterior angles of a convex polygon is 360 degrees. Triangle ABC is a convex polygon. Therefore, the sum of the exterior angles of triangle ABC is 360 degrees.
Valid.
So valid. Because it's saying exterior angles of a convex polygon is 360. Triangle ABC is a convex polygon, therefore it has the qualities that it will be 360. Again, valid. All frogs are green, Henry is a frog, therefore Henry is green. Valid. Valid, valid, valid. It must be all be valid, right?
Yeah, probably.
Can I change it?
Yeah.
Anybody else? Because he's not taking notes. Okay. Oh, there's more.
Oh.
If it rains, I will go to town. It did not rain. Therefore, I did not go to town. What's the group or what's the thing that has to happen?
Right.
If it rains, I will go to town. It didn't rain. Therefore, I did not go to town. Does it logically flow that because it did not rain, I have to not go to town? Does it say anything about that? This is actually invalid. Why? Why is that invalid? Give me an example. What else can happen? If it rains, I will go to town. So now the group is, if it rains, it'll have the characteristic of going to town. Are we placed into the group of, are we placed into the group in the second premise? No, we're placed into not raining. So therefore, I can't say that I'm going to have to not go to town. I still could go to town. I could not go to town. Here we go. How can I make this maybe a little bit easier? Let's construct our world. Our world right now is this big blank canvas of a rectangle. Everybody okay with that?
Yeah.
In this world, there is going to be something of going to town. Going to town, right? GTT. Going to town. In the world, there is going to be things that are going to town in it. And it happens to be that if it is raining, so now R, if it rains, anytime it rains, you are going to be within the circle of going to town. Does that make sense? So, if I'm here, I have to be on the going to town circle, therefore it's good. It says it did not rain. So, here's options. Could it not rain right there? And I'd still go to town, yes?
Yeah.
But could it rain right here? And then I don't go to town. So which one am I in? According to here, it just says it did not rain. We don't know. So therefore, I can't make the assumption that it's just I'm not going to town, because I could be inside here and still go to town. That's why it's invalid. It's not enough to say this is a good argument. What about 5? A car will not run without gas. I don't have any gas in my car, therefore my car will not run. So we're going to write this. I think this works, right? If no gas, then no run. Right? We're just thinking about the car. My car does not run. Therefore, no gas.
Oh, it's invalid because it's not talking about the gas.
So therefore, say no gas, which means no run.
Yeah.
Oh.
So wouldn't it be invalid?
No, it's valid.
Oh. Okay, now let's think of this. Going back to our little world idea.
Okay.
In the world, we have things that no run.
Whoa, wait. What were we doing?
We were doing number 5.
We did number 5.
We're doing
That's
number
why I'm
5.
confused.
That's not.
I started reading
Oh!
number 6.
Guys, I'm still. Whoa,
We have
wait,
to
wait.
say
5 is invalid.
Oh.
It is valid.
Oh, hold on.
See, I mixed them up.
Pause the video. Okay, 5. I'm going to say 5 is invalid.
Okay, yeah. But then
6
what
is
is
Okay, now, why? Let's construct the world. The world says that if it's a car, the car will not run, so the car is not running. So not run. Because there's a gas problem, right? No gas. So if there's no gas, hold on.
Oh my.
See, it might be valid.
Oh,
It is valid. It's hard.
you guys, our problem has another way to look at it. It's called look at the contrapositive. Contrapositive of the statement. Guys, the contrapositive says if
It's invalid.
if P then
It's invalid.
Q. Okay? Let's just talk about this.
6 is invalid.
Okay, we're gonna, ladies and gentlemen, I would pay attention to this.
Okay, are we talking about 5 or 6?
We're gonna, I'm giving you a clue to help us maybe in a different way. We can look up something called the contrapositive. If I have the if-then statement of if P, then Q, I can write the contrapositive. The contrapositive of this statement would be if not Q, then not P. So, let's take a look at our statement. We said if car not run, then no gas.
So then it would be valid.
No gas. We're stating there's no gas. Therefore, it won't run. No run.
Then it's valid.
So now, that was our original statement. We changed it to if-thens, and we kind of cleaned it up just a little bit to understand. So, what happens if I take the very first sentence here, change it to its contrapositive? I'm going to change colors. I'm running out of room here. So now, if gas, then run, no gas, therefore no run. Does it still place the object into
Yes.
the group?
Yes.
No. It does not relate to the fact that we still are not talking about the car having gas, it's saying not gas. The only way for this to work is if it's in the quality of not having, or the member of the car not having gas, or having gas in this case, then it will run. But I'm in a spot where I have no gas, which is a good thing for you guys. And then, therefore, it won't run. It's not valid. Okay, now, let's go back to 6. I'm going to erase this stuff out of here. So 5 is still invalid. Whoops, wrong. 5 is invalid because we don't have gas is not even one of the options that say that it would not run. It was the other way around. Your car didn't run because it didn't have gas. Therefore, it didn't have gas. Just because you don't have gas doesn't mean... It's a play on words, guys. That's what's making it so confusing. So, guys, so if not run without gas. A car will not run without gas. Then no gas. No run. Therefore, no gas. Does it place the car into the first group, therefore has the quality? Yes.
So that one's valid.
The car does not run, and if a car does not run, it has to have no gas. Boom. Valid.
Yes.
But that doesn't, you could argue that.
No.
It's like a sport problem.
Yeah, I thought you said there's a smart problem.
Lesson 7, page 57, 1 through 5. It's all on just if-then statements and writing contrapositives, switching, guys, like we did in that last problem to figure it out. And 1, valid, invalid.
Can I take a picture?